So we have to look at our balanced chemical equation here and see how many moles we're talking about. We've got 2 moles here, 1 mole here, and 2 moles over here. And this is important because, again, these heat of formations are kilojoules per mole. We got to know how many moles we're working with in each case. Well, obviously our total here is going to be 0, but it's still important for dimensional analysis purposes. Notice that moles have now canceled. This energy right here is just in kilojoules. Same deal over here. And same deal over here, only the math is going to be a little harder. There. So now that we have corrected our heats of formation to just total energy in kilojoules, we can now do our actual algebraic calculation. And here it is. If you want to calculate the delta H of a reaction using heat of formation values, kind of. You're right, this is going to look kind of scary. We got a big weird symbol there. Anyone know what the big weird symbol means?
Sigma.
Sigma, it's capital sigma, which means in math, the sum of. That's all this means. So our delta H is going to be the sum of all our delta HFs of our products minus the sum of all our delta HFs of our reactants. So our products, there's only one product, and we've already found its total delta HF, negative 43.6 kilojoules. And we're going to subtract from that the sum of all the heats of formations of our reactants, which in this case will simply be 0. And so our answer, which will be the delta H for the reaction, is right there. So that is how you use heats of formation to solve for the delta H of a chemical reaction. And we can tell several things from this. So for one thing, we can tell that's a fairly substantial amount of energy, isn't it? That's a lot of kilojoules. And also that negative sign tells us something very important as well. That negative sign tells us if we were to hold this reaction in our hand, you would feel heat coming off. This is a reaction that produces a lot of heat flowing outward from it to its surroundings. Any questions so far?